So now, having been done with tautomerization of D-glucose, in which we saw that glucose can be converted into D-fructose and D-mannose, we're going to move on to the next set of reaction that glucose does, and that is with phenylhydrazine. So we're going to cover the reaction with glucose, and it is going to be reacting with phenylhydrazine. Now, what is phenylhydrazine exactly? So, phenylhydrazine is a compound which is represented in this particular manner. So, it is NH2, NH, and pH. Okay, so this particular compound is known as phenylhydrazine, and here you can see the pH over here. This pH is nothing but phenyl group, and the rest one is hydro. NH2 has lost one H and it is replaced by phenyl group, so it is known as phenylhydrazine. Now, what this phenylhydrazine does is that when it comes in contact with our glucose, which we have just drawn over here, so you can see on the left hand side we've got a structure, and this is nothing but D-glucose, which we have memorized quite nicely now. So this is nothing but D-glucose, in which you can see an aldehyde group on the top, a CH2 group here, CH2OH group over here, and I can see OH, a lot of OH on the right and the second OH on the left. So we're very sure that this is nothing but D-glucose. Now, let us see what this phenylhydrazine is going to do with glucose. Now, phenylhydrazine, actually 3 moles of phenylhydrazine is going to react with our D-glucose, and what they're going to give is they're going to give us a new compound, and this new compound can be represented in such a manner. So we've got C, there'll be a double bond attached, and then we'll have N and NH, pH. One look at it and we know this N, NH and pH is coming from phenylhydrazine, and this second carbon also is going to follow suit with the first one and will show a similar structure. So here we have got two similar looking groups attached to our carbons, and the rest of the valencies, let us just fulfill them with the remaining groups. The rest of the groups looks exactly the same. So if you look at these 3 carbons, there is no change accompanied in here, and thus the structure looks exactly the same. So what we're going to change is the first 2 carbons, and that is going to lead to the formation of a new compound, which is known as, it is called osazone. So what is it known as? Osazone. So this particular compound is formed when D-glucose reacts with 3 moles of phenylhydrazine. This is our phenylhydrazine. So phenylhydrazine, 3 moles of it, when it is reacting with D-glucose, it is giving us osazone. Okay, so D-fructose, like D-glucose, will show this similar reaction with phenylhydrazine and will give us the same product. So it is going to give us osazone also. So if I have, let us say we have D fructose, this D fructose is going to react with phenylhydrazine, that is NH2, NH, and pH. And this particular reaction is going to give us the same product as we obtain from D-glucose, that is osazone. So here marking an arrow to show that this particular reaction, the D-fructose with the phenylhydrazine, is going to give us the same product that we obtained from D-glucose and phenylhydrazine, that was osazone. So both these reactions are going to give us the same product, that is osazone, and thus we have a reaction of D-glucose with phenylhydrazine, which gives us osazone.